Dear students, I am Dr. T. Manjula, Associate Professor, ECE, Hindustan College of Engineering and Technology. We will see the few points about fundamentals of digital electronics. The content in this presentation: introduction, characteristics of digital systems, analog versus digital systems, advantages, number systems, and logic gates. Introduction about digital systems. A digital system is an interconnection of digital modules. It is a system that manipulates the discrete elements of the information that is represented internally in the binary form. It represents the information with discrete symbols, of which digits are a special cases, rather than with a continuous varying quantity as in analog systems. Digital systems are wide in use variety of industrial and consumer products such as automated industrial machinery, pocket calculators, microprocessors, digital computers, digital watches, TV games, and the signal processing, and so on. Characteristics of digital systems. Digital system manipulates the discrete elements of the information. Discrete elements are nothing but the digits such as 10 decimal digits or 26 letters of alphabets, and so on. Digital systems uses the physical quantities called the signals to represent digital elements. In the digital systems, the signals have two discrete values and are those 4 said to be binary. In a digital system, signal represents one binary digit called a bit. The bit has a value of either 1 or 0. Analog system versus digital systems. Analog system, the processing information that varies continuously, that is, they process time varying signals that can be take any values across a continuous range of voltage, current, or any other physical parameters. In the case of digital systems, uses digital circuits that can process digital signals which can take either 0 or 1 for binary system. Analog electronics uses relatively high voltage and high current as compared to the digital systems. In the analog systems, high noise and distortion of signals is there. In the digital systems, there is very low noise and the very low distortion of the signals. Advantages of digital systems over analog system. Easy of programmability. Digital systems be used for different applications by simply changing the program without additional change in hardware. Reduction in the cost of hardware. Uses of digital components, and this can be possible due to the advance in the IC technologies. High speed. Digital processing of data ensures the high speed of operations due to the advances in the digital signal processing. High reliability. Highly reliable, one of the reasons for use of error detection and error correcting codes in the digital systems. Design is easy, which requires the use of Boolean algebra and other digital techniques which made the design of digital system made easy. Last one, the result can be reproduced easily. Unlike the analog systems, the digital systems are independent of temperature, noise, humidity, and the results can be produced easily. Next one, disadvantages of digital systems. It uses more energy, often fragile. Digital data are misinterpreted in larger blocks, manipulates the discrete elements. Quantization error may occur during the analog signal sampling. Number system. Number system is a basis for counting various items. Modern computers communicate and operate with the binary numbers which uses only digits of zeros and ones. For example, let us consider a decimal number of 18. This number is represented in the binary as 10010. We can observe that binary number system take more digits to represent the decimal number. For larger number systems, we have to deal with very large binary strings. So that other 3 new number systems have been used in the digital systems, that are octal number system, decimal number system, binary number system and hexadecimal number systems. The number systems classified into several types. Binary number system has a radix of 2. Only 2 digits are needed. There are zeros and ones. Weight is expressed as power of 2. Next one, decimal number system. It has 10 symbols 0, 1, 2, 3, etc. up to 9. In other words, it has a base of 10. Octal number system. For represent the large binary numbers, octal numbers uses a base of radix 8. It uses the first 8 digits of decimal number systems. It has digits from 0 to 7. Hexadecimal number system. This type of number system has a base of 16. There are 16 symbols. The decimal digits from 0 to 9 is used as the first 10 digits as in the decimal number system and followed by the letters A, B, C, D, E and F which represents the values 10, 11, 12, 13, 14 and 15 respectively. Then another number system is a BCD, that is binary coded decimal number system. Each decimal digits 0 through 9 is coded by a 4-bit binary number, that is 8, 4, 2 and 1. Weights are attached to it. It is a weighted code and it is highly used in the sequential circuits. The another name for BCD code is a 8421 number system. Next we will see the introduction about logic gates. Digital logic gates. Boolean functions are expressed in terms of AND gate, OR gate and NOT gate operations. It is easier to implement a Boolean function with these type of gates. Logic gate is an electronic circuit which performs the particular logic operations. These are also known as building blocks of the digital electronic circuits. Universal gates. NAND and NOR gates are called as universal gates. All the fundamental logic gates, that is NOT gate, AND gate, OR gate, can be realized by using either only NAND and NOR gates. It provides the flexibility and offers the enormous advantages to logic designers. This diagram shows the basic logical gates and the universal gates and its basic explanations. First one, NOT gate. NOT simply accepts an input and outputs the opposite. AND gate, all the inputs must be positive before the output is positive. NAND gate, same as AND gate but the outcome is inverse. So perform AND operation first, then apply the NOT to the output. OR gate, at least one input must be positive to give a positive output. All the inputs could also be positive. NOR gate, where F equal to A plus B the whole bar, same as OR gate but the outcome is inverse. XOR gate, only one input can be positive to give a positive output. XNOR gate, all the inputs must be positive or the same, either positive or negative, otherwise the output is negative. This diagram shows the truth table for all the logic gates. Summary of this presentation. A digital system represents the information with discrete signals. Two symbols often denoted by the binary digits either 0 or 1. The term digital system refers to the elements such as hardware, software and the networks and their users. There may be many different components that make up one system. For example, a computer has a central processing unit, a hard disk, keyboard, mouse, screens, etc. Every digital system has a digital computer, also called as microprocessor or a microcontroller, etc. Thank you for watching this video.